This is a run-through of how to create the intermediate Guess Who project. Unlike the beginner's project, in which the human is trying to guess what the computer has picked as a secret character, in this game, the human will pick a secret character and the computer is going to try and guess and be clever about finding out which character that is by asking the human questions, which the human will answer yes or no, and the computer will work out what the remaining characters are. So let's get started. Big thank you to everybody who helped creating this workbook, especially to the big team in Canberra who powered through getting the main part of the workbook all done together. So to get started, firstly, of course, I've set up a file. I've called mine Guess Who Intermediate, and the kids can do something like that too and save it on their desktop. And part 0.2 is just creating a comment so the kids know how to add a comment. And now we're off to the start. I should add that I am creating this in PyCharm rather than Python idle, just because my computer has a habit of crashing when I use Python idle and do a screen capture at the same time. So we're just using this for now, but very much the same. Okay, moving on to the start of the project. Writing a welcome message. We want the girls to print out the instructions for the game, essentially, and we've got a big long multi-line instructions, so we're going to use a triple quote to do that, and we're going to grab the welcome message from the website to save typing that all out. And here we go, we've got that. We can run that and we get our welcome message. Hooray! Okay, so next up, we're copying in our list of people. So how this game is going to work is the students are going to have one of these Guess Who people sheets, and that's where they're going to be picking their characters from. There's also spots to add more people at the end later, and they'll also need to add that to the corresponding list that the computer receives. So that's this list here. At the moment, it has the 12 characters that we've defined, and then they can add more later if they add more to their sheet. So we're going to start by copying this in, and we're going to put it at the top of our file, or somewhere, doesn't really matter, as long as it's near the start before we start using it. So I'm going to paste that in, put our list of people. Okay, so the next step of this is we need to choose a character that we're going to get the computer to guess. Just as, as a start, I'm going to start by being Alicia. And that is what they will be. The computer will try and guess, just so we just have to keep that one in mind while we're getting started before we get our game fully functioning and we can start choosing all different people and playing over and over again. So let's start by getting the computer to know about all the different options we have for the different features. So the features we have here are the name, the eye color, the hair color, and the accessory. And we need a list of the things that the computer can guess. So later on there will be an extension on using files where we create this list dynamically, but for now we're just going to hard code this list, and it's going to have all the different options for eye colors, hair colors, and accessories. So things we have for eye color, and we're just going to create a list for each of these, is we have brown, we have blue, we have green, hazel. For eye colors, hair colors, we have black, we have red, brown, and blonde. And for accessories, we have hat, glasses, and none. Okay, cool. So we've got our lists. We're going to use these later for when the computer is trying to guess eye color, hair color, accessory. So we now need to get some guesses from the computer for what it thinks each of these are. So we're going to start by getting it to guess, choose something from the list of eye colors, and then that will be our guess, at least initially. So we're just going to start by guessing the first one. So we're going to have our eye guess equal to eye colors, and we're going to take the 0th item. So don't forget to index from 0. We need to also repeat this for the hair guess and the accessory guess. Okay, so now that we have the things we want to guess, we need to make the computer actually guess them. So that's this section here. Yeah, 2.3. So we need to actually get the computer to ask the question of the human. So we're going to call these the answers to these questions that we get back. I guess answer, hair guess answer, accessory answer. I guess answer equals input. And we would like to ask, are there eyes? And then we'll need to do a string concatenation here. We can't do that same comma trick we do with print in input, and it takes one argument, so we're going to do I guess. And then we're going to get the hair guess answer. Is there hair guess? Finally, we get accessory guess answer input is there accessory guess. So now we have these questions and we can run it and we'll see. Welcome to Guess Who, and then we get are their eyes brown? Oh, we should have added some extra space after these, so maybe we'll add in a question mark after all of these. Are their eyes brown? Who are we being? We're being Alicia. Yes. Is their hair red? Nope. Is their accessory? None. No, they're wearing a hat. Okay, so now we've got that working. We want to actually be able to do something with these yes or no answers. Also, as we saw, we could have typed in yes or no with different capitalizations, so we might want to add this extension, which is bonus 2.4, which is lowering all the answers the human puts in case they enter something differently. So now if we do something else, we could do yes, we can do no, we can do yes, something like that. So that will help us out later if our friends who are playing our game use different capitalizations. So now we've got that, we want to actually do something with this information and help us narrow down our selection of people the computer can choose as their guess. So we're going to start by looking at one person in the list and then seeing if they need to be eliminated from the list of possible people. So let's start. We're going to start with, we're going through this list like this. We're going to loop through, and the first person we're going to look at just individually before we add the loop is the 0th item in the list. So we're going to select person, and it's going to be people, our list above. We're going to get the 0th item, and we're going to do a comparison and see if they should be eliminated. So we've selected this person, and we're going to print them out. Print out person. We're going to give that a run. And then we're going to get all of these parts. Answer these questions, and we get that. We've seen we've selected that person, the 0th item in the list, which was Alicia. Now, we need to check these facts that we've got about them. So, we're going to do this by splitting out the character features of the person. So we're using Alicia here, and we're going to split out Alicia into the 4 parts that make up Alicia. So we've got person name equals person, and we're going to get the 0th item. Got person eyes. Person eye is person, and that's the next item in the list. Person hair is the following, and finally person accessory is the 3rd item there. So we've split them all out. And want to check, do a comparison between what our guess was and what the person we're inspecting right now for potential elimination is. So this part here, 3.3, it's just a practice activity. It's basically playing Guess Who, the actual game here, and just seeing, like, showing them how elimination works. So we're going to just get the kids to cross off anybody who has a particular feature. So if the computer had asked, do they have brown hair, in this activity we would get Alicia and possibly George and Kevin. This will be updated so we actually have stats of the people next to them, so we don't have to inspect quite so closely. And we would cross them off, just like how we turn down the flaps in actual Guess Who. So once they see that that's how we eliminate people, by inspecting a specific feature of them and then crossing them off, we're going to do that with code. We've got some tables here to get them to practice doing that, because it's a complex logical combination here, because we have a few things at play. We have the actual character and the feature that they have. So they might have here blue eyes, they might have blue eyes. And now we have the guess feature. So we might have asked, do they have blue eyes? And then we want to have a yes answer if we want to keep them. If we got no, if you had guessed, if your character in question didn't have blue eyes, then you would want to eliminate them. However, we would also want to keep them in the game if you guessed not blue eyes, and then the character didn't have blue eyes. So there's 2 possibilities for keeping them, and there's 2 possibilities for eliminating them. Both, either, they both match or they both don't match. And we're going to get the girls to fill this out for a hair option and for an accessory option to see this complex combination where we have three pieces of data that kind of tie in to bring us the match. Okay, so how do we actually code this? We're going to have a bunch of if statements coming up now. Okay, so now we know the ways we can eliminate a character. And what we look at here, we want to encapsulate all these eliminations into an if-elif kind of chain to build up a list of people we're going to eliminate from the game. So we will want to turn down a flap if we receive a yes answer for a feature. So say we've guessed, do they have brown eyes? And then we are inspecting, and they've said yes, and then we're inspecting a character that doesn't have brown eyes. So if I'm looking at a character, they have blue eyes, and I've been told yes, they have brown eyes, then that character no longer needs to be in the game. So let's try and encapsulate this logic. So we've got if I guess answer equals no. We've got a no. And the character we're looking at has eyes that do match the color we've guessed. So we've got I guess answer. We've got I guess equals person I. So we're saying yes, the thing you guessed and the person we're currently inspecting for elimination do match, and that was incorrect. Then we want to get rid of them. So then in this case, we're just going to start by printing out eye color does not match. Make that a string. Maybe we want to say eliminate or something, because we'll get to the actual elimination shortly. So that's one of the I options. We also have the I guess answer could be correct. And the person, the I guess, does not match the person I, then we want to have that same elimination about to occur. And then we want to repeat these for hair and accessories. But let's give this a run first and see if we've got our thing working, because it's fairly complex logic. It's got a lot going on. So let's say we are being Alicia, who has brown eyes. Are their eyes brown? Yes. And then we'll just make the rest of this up. So Alicia has not been eliminated. That's good to know. Let's try and be Dave, who has blue eyes. No. And then some other answers for these ones, doesn't matter. And we have eliminated Alicia, because that's the character we're inspecting. Let's do one more, because it's a bit confusing when we deal with Alicia in both scenarios. So let's be Kevin, who does have brown eyes. So yes, they do have brown eyes. And then whatever these ones. So we haven't eliminated Alicia, which is good because we are Kevin, but all we know right now is that the character has brown eyes. So Alicia also stays in the game because Alicia is currently the person we are inspecting. And we will shortly loop through all of them to eliminate anybody who doesn't have the matching features. But first, we need to repeat this part for the hair color and the accessory. So we're going to change this to hair guess. And so hair guess answer. And then we have the guess and the person we're inspecting. So that's the character we're looking at right now for potential elimination. And we're going to repeat this on this line. And finally, one more for the accessory. Great. Okay, so give this a run, make sure it works. Say yes, no, yes. And would we have eliminated Alicia based on this one? Because we're only looking at Alicia right now. Are the eyes brown? Yes. So they wouldn't be eliminated for that. So we haven't done that. We've only got one elimination factor because we've only got this printed out once. Is their hair red? No. No, we should have also updated the eye color parts. So we're going to have these parts for hair, and then accessory. Here we go. Let's try this again. eyes brown, yes. Let's make up some random answers. Yes, no, yes. So if the computer asks these questions and these are the answers we guess I gave because it was some random character, would Alicia be eliminated? Yes, we would eliminate them based on the accessory, because it said, is there accessory none? And it said yes, and then we would have a hat. Now, an interesting thing here is the reason we've put this in one big chain of if, elif, 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 elif. Because we could have done if, elif, if, elif, if, elif, dealing with the different cases individually. But we only want to get one of these messages printed out, because what's going to happen in a second is we're going to create a list of all the people to be eliminated. And we don't want to put people into that list multiple times. We only want them to be eliminated once, otherwise later when we try to eliminate them and we've already eliminated them, we'll get an error. So we're just preventing the kids from doing that. So we do an example where we were trying, for instance, we were going to eliminate Alicia based on both their hair color and the hat. So let's run this one more time. We want to say, are the eyes brown? Yes, that's a match. But their hair color, is it red? And we said yes, we want to eliminate based on hair color. And if the accessory is yes, we don't want to match on that. We want to eliminate based because of the hat. We want to see that only one thing's printed out. We've said we don't want to match based on hair color. So we never actually get to checking the hat because we get stopped in the hair color section, which is great because we only want to know if there's one reason to eliminate them. So this is something to remember if the kids are getting stuck, or later if we're having an error, an indexing out of range error for elimination. So now we've got that, we've got all that code, we can move on to the next section. Elimination time. So we've looked at the first character, we've only ever been judging Alicia to see if Alicia should be kept in or eliminated. We're going to now loop through all of the characters and add them to a list as we go along to prepare them to be eliminated later. So we're doing this in 2 steps. Unlike the game, when you play Guess Who, you look at one and if it's wrong, you put it down straight away. We're doing it 2 steps. We're going to create a list of things we want to eliminate, and then we're going to go through and do it in the next part. So we're going to start by adding a for loop. So above this section here, I'm going to add for person in people. So we can get rid of this person line. That's where we were just getting our demo person. Now we can print out the person, and we're going to do this judgment for each of them. We need to remember to indent all of this code. So this looks through everybody, and let's just give it a run and see what it does actually. So let's answer some questions. We get each person printed out and whether or not they are eliminated. Looks like I've created an example in which I've eliminated everybody. Let's run one more time. Let's pick a person to be at random. Let's be Eve. And Eve has green eyes, glasses, and brown hair. Say yes, no, we don't have brown eyes. We have not got red hair, and the accessory is not none. So we still have a few characters in the game. We don't see those elimination messages for. Charlie's still in. Frankie and Eve is still in, and Jackie's still in. So those are the people we want to keep in the game. But that's not how we're going to do it. We're actually going to look for all of the places where elimination has happened. So back here we go. We need to keep track of all these people who are going to get eliminated. So we're going to start by, before our loop, creating a list to eliminate. It's just an empty list, and we're going to add to it. So instead of printing out these eliminations necessarily, we could just do the append to eliminate that we want. So we want to add the person to this list, so we're going to append person. let's go through and add it in all of these sections. All the different ways to be eliminated. Great. And we can get rid of those prints now. Okay, now we have our list of people to eliminate, and now it's time to actually remove them from our original list. So after this for loop, we're going to create another for loop. And we're going to live through the list of people. And we are going to remove them from that list. From the original list. Well, so we're going to go through the elimination list, sorry. So for person in eliminate, so those are all the eliminated characters. Eliminate. We are going to do people.remove and then that person. Then let's go and print out people at the end and see who we've got left. So our previous one I did was no, 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 when we should have it. Just a few people left in this list. So we have Charlie, we have Eve, we have Frankie, we have Jackie. And that's the people we saw before when we were doing that example. If we answered no to all those questions. So that's good. Now we want to make the computer make a guess to the human. So we're going to get rid of this print line and we'll select a guess from the people who haven't been eliminated. So our list of people. We're just going to start by choosing the first person in the list. So pick the first person. Then we're going to get the name out. So guess name is equal to guess 0. And then we're going to ask the human to confirm or deny that it's a person. So we'll answer, store in answer. We're going to have input, is it, then guess name, and then a question mark in space. Let's give that a go. Go. No, no, no. Is it Charlie? And then we get to answer yes. I think we're being Eve. Let's say no, it's not Charlie. And then that's all it does so far. Computer guesses right. It's time to celebrate and print out that they've won. If it's the wrong answer, the person needs to be removed from the list because shortly we're going to loop back around and give them another chance to get it right. So let's start with if guess name, okay. If answer equals yes, print yay, you win. Else, we want to remove that person from the list. So people dot remove, and we need to remove the whole person rather than just the name because the list is created and made of those whole lists of lists. So we're going to remove guess rather than guess name. Okay. So let's see what happens if we print out people here. Let's say no. Oop. I'm going to type in here. No, no, no. Is it Charlie? No. And we've now eliminated Charlie from the list. Let's run it one more time. And we're going to say no, 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 no. And we're going to say, is it Charlie? And let's say we were Charlie. And it would say, yay, you win. And Charlie is still on the list. And, well, that's the end of the game. So it doesn't really matter who else is in the list anymore. Okay, cool. So we've got that working. Time to make it choose better guesses, because at the moment it's always going to choose the first thing in our list of possible eye colors, hair colors, and accessories. Oh, I should have made these all zeros. It's just going to choose the first ones there rather than these ones. That's what we're going for. But it doesn't really matter for that example. What we're going to do now is make it choose a random thing. So it's going to randomly pick a different thing to ask. Otherwise, it would be a very predictable game, and you'd know how to win just by choosing something that the computer would not ever guess. So we're going to start by going to the top. Importing random. Okay, now we're going to do random.choice, eye color, and we're going to repeat that for these ones. Choosing something from that list randomly. So we've now done that for all the different parts. And then we also want to do it so it randomly chooses someone from the list to guess rather than choosing the first one again. Makes it easy for us to cheat as a human. Okay, cool. So now we can play again. Now we've been asked if the eye's green, which is new. Let's say yes. Is the hair brown? Yes. Have they got accessory? None. No, keep getting none before. We got Charlie. Well, we've already done Charlie. Let's do it one more time. Play again. Say no. Blonde. That's new. Keep getting the same accessory. That's not that exciting. Is it Jackie? That's new. Say yes, it's Jackie. Maybe this time we'll get a different accessory. No. No. A hat. Say yes to a hat. Is it Kevin? So now we can see we've got our real Guess Who game happening. Except if you don't get it right, guess the first time, well then it's all over. So it's on to the next time. We need to create a while loop that is going to let us keep playing until we actually guess the right thing. So the parts of the game we want to repeat are the parts where the computer guesses a different thing, and then we confirm or deny if those facts are true. Then it does the elimination, then it makes a guess for who the person is, and then it prints out if you've won, or it removes the person if you haven't. And then we want it to start again. So we're going to start our while loop here. While loop, while true. And we're going to highlight all the way down to here. And, well, we'll keep this print statement in for now because it's fun. Okay. So we've got that happening now. And then we're going to need to break the loop if we've won the game. So we're going to put in our break here. But otherwise, it will keep playing even when we've won. Finally, before we've done, now we want to, now we're making multiple guesses. We have to be careful when we're removing people from the list. So we need to make sure we are always recreating this list, which is happening here every time. So make sure that is inside the loop, because we could have started by maybe having this up here. So that's just a note to the kids in case they have put that somewhere different. Okay, let's give it a go. No. 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 Brittany. No. Does it start again? Yes, it starts again. Oops. And we sometimes get an error because I've just been making up random guesses and I made something that doesn't fit the build of any of these characters. So let's play for real. Let's be Frankie. Are their eyes hazel? No. Their hair blonde? Nope. They're not wearing glasses. Are they Alicia? No, they're not Alicia. Their eyes hazel? No. Is their hair brown? Nope, looks black to me. Is their accessory a hat? Yes. Is it Kevin? No. Are their eyes blue? No. I think this is going to end badly. That list looks like it was empty. Is their hair black? Yes. Accessories, glasses? No. Okay, let's have a look at what does Frankie actually look like. Hazel? Oh, they are hazel. We're going to work on these eye colors. Hazel, black and a hat. Let's play one more time. Let's be Frankie. Yes, they do have hazel eyes. Not blonde hair, not glasses. Is it Frankie? Yes! Very good, computer. So, that looks like we have a Guess Who game right there. And we can say here, which deals with the thing that we just found out, is that sometimes if you lie to the computer or you guess it wrong and tell it the wrong facts, it will run out of options to guess, and it will tell you, you can code it so you can tell, it will tell you that you're a liar because you've made a possibility that doesn't exist. So that is the intermediate Guess Who workbook. That's pretty fun. There's some extensions for making smarter guessing. At the moment it has, if once it's already guessed the correct hair color or something, it's still going to keep asking you randomly what the hair color is. And also it's going to randomly say the same one several times. So if something has already asked you if it's got black hair and it's found out no, you would want to move on to brown hair or a different color the next time. So that is a way to narrow down your possible looks so you don't keep asking the same question, especially if you keep getting the answer no. That's one extension. Here's one on files. If you are doing the advanced classroom, we're going to be using this files extension as a basis for, we're going to start with the intermediate workbook and then add this extension before moving on to the advanced workbook, which plays the other half of the game where the human guesses. So yep, that's just to get this people list read in, and then also we'll need to generate these lists dynamically. And those are the extensions for the project. So thank you for joining me for intermediate Guess Who. I hope to see you at a workshop soon.